Alright, in this video I'm just going to be working some stoichiometry examples. Let's look at this problem here. It says if you were given 100 milliliters of 0.05 molar HCl, how many grams of sodium bicarbonate will you need to neutralize it, and how many grams of each of the products will you form? So in this one, we're starting with 100 milliliters of HCl, and we need to go a couple different places. We need to go to grams of NaHCO3 that are needed, and then also the grams of each of the products. But we don't have even a reaction yet. So the first thing to be able to do to do a stoichiometry problem is you need to get a reaction going. So we've got HCl plus NaHCO3. This is the same reaction we did in the stoichiometry of the balloon races. So this makes H2O, CO2, and Na2CO3. No, sorry, NaCl. Paying attention. NaCl, and it's all one-to-one stoichiometry. It's all balanced out. Okay, so we want to find grams of NaHCO3, we want to find grams of H2O, grams of CO2, grams of NaCl. Okay, so we're starting with, in all the cases, we're starting with the volume of A, so A is HCl. We want to go to molarity, use molarity to go to moles of A. Once we have moles of A, go to moles of B. Once we have moles of B, actually, sorry, we don't want to do this. We want to go, in each case, to mass. Okay, so starting off with the volume, I have 100 milliliters, which is the same thing as 0.100 liters of HCl. If I want to go now to moles of A, I use the molarity, so it's 0.05 moles per liter. So that will give me moles of A. So if I take and multiply those things, I have 0.005 moles of HCl. Okay. From there, I have to go to several different moles. Okay. So I start with my 0.005 moles of HCl. And I want to get rid of HCl. So my reaction says there's one HCl. And if I want to go into NaHCO3, there's also one NaHCO3. So it's one-to-one stoichiometry. And so I'm going to make, or need, 0.005 moles of NaHCO3. And in fact, it's all one-to-one stoichiometry. So this number of moles is also going to work for H2O and CO2 and NaCl. It's going to work for all of them because of the fact that all of them are just one in the reaction. So it's one of each of them. Okay. So now once I have moles of B, so I've got my moles of NaHCO3, now it's just a matter of going to the mass of NaHCO3. So I take my 0.005 moles of NaHCO3 and I multiply by its molar mass, grams per mole. Okay, and so for this NaHCO3, it's 84.01 grams is 1 mole for that. So I multiply that out. So it's 0.42, or with the number of significant digits, sorry, 0.420 grams. Okay, so that's an example. For the rest of them, if I want H2O, I would just multiply by its molar mass of 18.01. If I want CO2, I would multiply by 44.01, which is it. And if I wanted Cl I would multiply by 58.44 for that one. I want to take a minute and just look at another way to organize stoichiometry. This is the way I actually like to do it. Still keeping that roadmap in your mind of like, here's how to organize things. But I always like to take and write the reaction out and make a table underneath it. And in my table, I look at, first of all, what is my given amount? So if I look at what was I given? I was given how much HCl I'm started with. Okay? And then from there, I realized in my roadmap, the first thing I'm going to have to do is go from that given amount to the moles of substance. So then I just go, okay, well, that's how I get the moles of the one I was given. And then from there, I need to get the moles that I need. So I look at, well, how do I get moles that I need? Okay? And since they're all one-to-one stoichiometry, the moles is the same in all cases. Okay? And then finally I look at, well, what's the needed amount? Well, for NaHCO3, I needed from the problem to get its grams. For NaCl, I needed to get its grams. For water and CO2, I also need to get their grams. Okay, and didn't show all the workflow. So I like to organize things into a table, and I think we'll work one more problem as an example and look at this way of organizing things. Yep. All right, for this next calculation, I'm going to look at, I want to answer how many grams of lead iodide will be formed from the reaction of 15 milliliters of 0.1 molar NaI in excess of lead nitrate. So I still want to keep in mind that I want to go from, with my roadmap, I'm going to go from the mass of A to the moles of A to the moles of B to the mass of B. But I'm just going to use this chart here to organize myself. So first I need the reaction. So I'm reacting NaI with lead 2 nitrate, so that would be Pb NO3 and I'm making lead iodide, PbI2, and then sodium nitrate. Before I do any stoichiometry, I need to make sure it's a balanced reaction. So I have 2 nitrates here, so I need to have 2 sodium nitrates. It means I have 2 sodiums, 2 sodium iodides, and then that's 2 I's and 2 I's, so that's good. Now I look at my problem. What are my given amounts? I was given 15 milliliters of 0.1 molar NaI. And I suppose I don't need to write it in there because it's already in that column. And then I look at, well, what do I need? I need to find out the mass of lead iodide, so eventually I want to get here. Okay, so the first thing I need to do is figure out how many moles of this given substance am I starting with. So I take my volume, 0.015 liters, because that's what 15 milliliters is, and I multiply by 0.1 moles per 1 liter. So I have 0.0015 moles. Now I have to look at, well, how many moles of the one I need do I have? So I take my 0.0015 moles and I multiply by the ratio of 1 lead iodide for every 2 sodium iodides. So when I find out what that equals, that would be 0.00075 moles. And then to get the needed amount, now I'm going to take that moles and turn it into mass. So take my 0.00075 moles, and I'm going to multiply by the molar mass, how many grams per mole lead iodide is. So first I got to figure out what lead iodide is. So I take and I add up the molar mass of lead. So lead is Pb plus twice the molar mass of iodide. And I get 461 approximately grams per mole. And And so when I multiply together, I would get 0.35 grams of lead iodide. All right, so hopefully this helps, and we'll be working a couple examples in class as well.